Here we have a timer assembly. This is a dishwasher timer. So the timer have different parts. You have the cam, you have the switch contacts on this side, you have the cam followers, and you have the timer motor. So the timer, the definition for a timer is a series of switches that's controlled by a cam that controls many different electrical circuits. So this is your cam. So when the timer motor turns, it's moving the cam follower. So if you look, you'll see the cam follower is carrying. So on each of these cam followers, we have a contact. So your it's making and opening different circuits at different time. So again, the definition for a timer is simply a series of switches that's controlled by a cam that control many different electrical circuits. The cam is turned by the timer motor. So as soon as you turn it on, it's a synchronous motor that keeps turning. So that's pretty much a timer. All right, so we have a pressure switch. The pressure switch is a single pole double throw switch. So when the washer is empty, the purple wire is the normally closed position. So the water enters the tub. You have an air dome. It's going to create air pressure. The air pressure is going to be connected to the switch. There's a diaphragm in the switch that will move to open the contact to the water valve and close the contact to the motor circuit when it senses enough pressure. So we're going to go over to the actual pressure switch right now so we can see what's in it and how it works. So here we have a pressure switch that's open up. So it looks like this. There's a tube that's connected. This tube is connected to the side of the tub. So as the water enters the tub, it creates pressure. Now that pressure that goes into here is activated the diaphragm. So this diaphragm will expand our contract. So if we pull the diaphragm up, you'll see that we do have contacts inside here. So these are where the contacts are. So the diaphragm is technically pushing down on this spring, making or breaking the contact that we need. So in reality, it's using the air pressure to break the circuit, and the air pressure is created in the air dome by the water entering the tub. So here we have a centrifugal switch on a direct drive washer. On this centrifugal switch, you have the contact that's in series with the start winding. So the purpose of the centrifugal switch is to remove the start winding when it gets to about 75% of the RPM. So, and this one, it also allows current to flow to the run winding at the same time. But again, the main purpose is to shut the start winding off when the motor gets to a certain RPM. So the centrifugal switch is opening based on centrifugal force. So we're going to look at a motor to see how it's done in the Whirlpool motor. Here, we have a dryer motor. This is a Whirlpool dryer motor. This is our centrifugal switch that's going to control the start, that's going to take the start winding out of the circuit. On a dryer, it also closes the circuit to the heater. So if we look inside here, the centrifugal switch, we'll see all these contacts right here. So these little points, that's your contact. This white part, that's my part, that's the arm that's connected to the motor. When the motor starts to turn, it creates a centrifugal force. So if you look over here, when the motor's turning, this is going to simulate a motor that's turning. So if you look in, so the motor's turning, if you look at the switch, it's opening or closing based on the motor operation. Again, this motor does two functions in a dryer. It opens the start winding and it closes the heater. So if we had to guess on this contact, this one is normally closed right here. So this would be probably the contact that controls the start winding. When the motor starts to turn, it should open, and the one that closes is the one that controls the heater. Again, that's the centrifugal switch on a split phase motor. It takes the start winding out of the circuit. All right, so here we have a regular magnetic relay. A relay is an electromagnetic switch. So this is a start relay. So the relay has two parts. You have your coil and you have your contact. Your coil is in series with your run winding. Your contact is in series with your start winding. So if we trace the circuit here, will see that we have a complete path for current to flow through my run winding. My start winding, however, we don't have a complete path because the switch is open. Alright? So right now the motor is trying to run, but it can't run unless it starts. So we're building a current in the run winding. So at normal running, when the compressor is running normally, it doesn't have enough current flowing through the circuit to create a magnetism. But in the beginning, when it's trying to run, it's building up an excessive current. That excessive current that's built up here is also over here because it's in series. So whatever the current here is, the current will be here. So that excessive current buildup is enough to create a magnetism. That magnetism is going to close this contact. Once that contact closes, your compressor will start and it will run. Now that it's running, that excessive current will go back to normal. Like I said earlier, that normal current flow is not enough to maintain a magnetism, so the contact will open. So that's how it starts the motor and also take the start winding out of the circuit. Alright, so we have a thermostat, and this is a mechanical old school thermostat. The way I describe it is we have different parts. So here we have our switch contacts. When the switch is closed, we have a complete circuit to your compressor. So the compressor is going to run, it's going to cool the area down. So the parts that we have a sensing bulb. The sensing bulb is going to be in the area that we need to monitor. So if it's an oven, it will be in the oven cavity. If it's a refrigerator, it'll be in the refrigerator compartment. We have a connecting tube that goes to the actual thermostat, and in that tube we have some kind of liquid. That liquid will expand or contract based on the temperatures. We have a bellow, and that expansion or contraction is gonna push this bellow. When it does that, it's gonna close the contact. So again, it needs all those things to work. So we have the sensing bulb that senses the temperature. We have the liquid inside here that's gonna boil or expand our contract. That's gonna control the action of this bellow. This bellow is what's gonna open or close this switch to control the compressor.
Square.